Hello everyone, welcome back to my channel. This is once again Teacher Chan, your math companion. But before we continue to our topic for today, let me first give you the answer of the previous video's question. And that was, what is the biggest three-digit number that is divisible by 2, 5, and 10? Now to answer that question, let us try to check if all your answers in the comment section are correct. You have to think of the number, the biggest number that is divisible by 10. Because once it is divisible by 10, then it is already divisible by 5 and 2. Or what do you think is the three-digit, the biggest three-digit that is divisible by 10? Anybody? Yes. Remember, of course, we have to start by 9. After that, another 9. And then, should I write 9 here? Because we're looking for the biggest digit? No, because it is not divisible by 10. So what do you think is the missing digit here? Yes, it is. It's 0. So the answer is 990. Very good. So for those who answered correctly, congratulations. And for those who did not make it, better luck next time. To continue with our lesson, today we're going to discuss about divisibility rules. 3, 6, and 9. So I have here a problem for us to start. Alright? Let me read this for you. Chef Franco bakes brownies to earn extra money, and he makes 441 pieces. Too many. And plans to arrange them in boxes of 3, 6, or 9. He's referring to 369. To put all the 441 pieces of brownies, what do you think? Is it possible for him to pack those brownies in 3s, 6, and 9s? Let's find out. And the divisibility rule, numbers 3, 6, and 9 will help us. Now, what does it state in divisibility rule number 3? Now, according to the divisibility rule number 3, says here that to check if it is divisible by 3, how to get first the sum. What do we mean by the word sum here? Sum means the answer of addition. We have to get first the sum of the digits, all these digits. I have to give example later. And check if it's divisible by 3. Now, for you to understand it more clearly, I have to cite an example for you. I have here 504. Now, if we are going to check this by using the traditional way of dividing, like the division process, it will take us much time. So by just adding all the digits and check if it's a multiple of 3 or if it's divisible by 3, then it will shorten our time. So let's try to check this. What are the digits in 504? First digit is, from the left, definitely it's 5. Plus, have to use plus sign because we're getting the sum here. Next digit, 0. And the last digit is correct, it's 4. Now, by using the mental computation, what do you think is the answer? 5 plus 0 plus 4. Definitely it is. It's 9. Now, let's try to decide. Is 9 divisible by 3? Absolutely, it is divisible by 3. Because 9 divided by 3 is 3 without remainder. There is no remainder. Therefore, we can say now that 504 is divisible by 3. Look at that. It shortens our computation. Another example. I have here 1,326. Do you think this number here is divisible by 3? Let's try to find it out by adding all the digits. I have here 1, plus 3, plus 2, plus 6. Now what do you think is the sum of 1 plus 3 plus 2 plus 6? It is? Yes. The sum is 12. Because 1 plus 3 is 4, and 4 plus 2 is 6, and 6 plus 6 is 12. Now, let's try to think of this number here, or the sum here. Is divisible by 3? Definitely, because 12 is a multiple of 3. Try to skip count, like 3, 6, 9, 12. And there is no definitely remainder. So we're going to say now that this 1,326 is divisible by 3. Last example. I have here 973. Let's try to add first all the digits. What is 9 plus 7 plus 3? Yes, it is. We add first the 7 plus 3. It's 10 plus 9. That will give us 19. Now, is 19 divisible by 3? No, because if we're going to skip count like 3, 6, 9, 12, 15, 18, 21, then there is no 19 in the multiples of 3. Right? Because if we divide this by 3, that will give us what? That will give us 6, remainder 1. So we say that this number here, the 973, is not divisible by 3. Alright, since that you know already how to get the sum of all the digits to check if it's divisible by 3, then we can move already to the next divisibility rule. And that is the divisibility rule number 6. Now, what is the condition in divisibility rule number 6? Now, according to its statement here, a number is divisible by 6 when it is divisible by both 2 and 3. It has to satisfy both conditions. First, it should be divisible by 2, and second, it must be divisible by 3. So, if you did not watch yet my first video about divisibility rules number 2, 5, and 10, then you better watch it first so you can continue watching on this and you can understand really about the divisibility rule number 6. Now, let's try to check it by using the divisibility test. Now, say for example, I have here 444. Now, this 3-digit number here, do you think it is divisible by 6? Of course, we have to check it first by using the divisibility test. So by using this, first we're going to check if it's divisible by 2, and second, if we're going to check if it's divisible by 3. So once it satisfies both conditions, then we must say that it's also divisible by 6. Are you ready? Let's begin. First, is it divisible by 2? Remember, divisibility rule number 2, it has to be even. Now, what is the last digit of this number? It's 4. Is it even? Yes. So we have to put check here. Next, to check if it's divisible by 3, we just have to add all the digits. Now, what is the sum? 4 plus 4 plus 4. What do you think is the answer? 3/4. Yes, it's 12. So we say, since the 12 is a multiple of 3, 3, 6, 9, 12, then we say that this number here is also divisible by 3. So we place check mark here, and it satisfies both conditions already. It is divisible by 2, and it is divisible by 3, so we can now say that it is also divisible by 6. Now, yes, it's a little tasky because you have to check first the divisibility rule number 2 and 3 before you can confirm that it's divisible by 6. Alright? Next example. I have here 9,107. This 9,107 here, a 4-digit number, do you think it is divisible by 6? Okay, we cannot proceed unless we check it first by divisibility number 2 and 3. First, is it divisible by 2? Is it even, the last digit? It is not even, right? Because it ends with 7, and 7 is odd number, or odd digit. So we say that it is not divisible by 2. We place X mark there. So we can no longer proceed. Because once a digit is not even, then it is not also divisible by 6. Did you get me? Alright. So that is how we're going to check the divisibility rule number 6. It's time for us to proceed to the divisibility rule number 9. Now, when do we say a number is divisible by 9? We say that a number is divisible by 9 if the sum of all the digits is also divisible by 9. Yes, it sounds similar to the divisibility rule number 3. Because in divisibility rule number 3, it says that to get or to check the number if it's divisible by 3, have to get first the sum and then try to check. Same with 9. Get first the sum of all the digits and then check if it's divisible by 9. Are you ready? Let's try to check this number here. So I have here 247,401. Again, I have here 247,201. And let's try to find out if this number is divisible by 9. First step, know the digits. Identify the digits. What are the digits? We have 2, 4, 7, 4, 0, and 1. Are you ready to add them? Let's begin. 2 plus 4 plus 7 plus 4 again plus 0 and plus 1. Can you please help me add those digits? What do you think is the sum? Yes. 2 plus 4 is 6. Plus 7 is, it is 13. 13 plus 4, definitely 17. 17 plus 1, it is 18. The sum is 18. Now, do you think 18 is a multiple of 9? Or do you think 18 is divisible by 9? If you're going to try to divide 18 by 9, do you think it can give us an equal quotient, like exact quotient without the remainder? What is 18 divided by 9, by the way? Yes, it is. It's 2, with no remainder. Since there is no remainder, it means to say that this number here, the 247,401, is divisible by 9. Very good. Divisible by 9. Exactly. Now, another example. I have here 243,094. Do you think this number here is divisible by 9? Let's try to check first by adding all the digits. Are you ready? Alright. What is 2? What is 2 plus 4? It's 6. 6 plus 3. Yes, it's 9. 9 plus 0. The same answer, 9. 9 plus 9. It's 18. And 18 plus 4 is, it's 22. Is 22 a multiple of 9? If we're going to skip count from 9, say 9, 18, 27, 36. Did I mention 22? Yes, because 22 is not a multiple of 9. Definitely, we can already say that this big number here, the 240,094, is not divisible by 9. Alright? So since that you know already the divisibility rules number 3, divisibility rule number 6 and 9, then it's time for us to proceed and answer the problem that was given earlier. Now to answer the problem, I have here the divisibility test table. Let's start. Again, the question is, can chef use any box size to put all the 441 pieces of brownies? Now to know if it's divisible by 3, 6, and 9, have to check it one by one. Have to place first the number 441. Then let's try to check if it's divisible by 3. What is again the divisibility rule number 3? Add all the digits to see if it's divisible by 3. Then 4 plus 4 is correct, it's 8. 8 plus 1 is right, it's 9. And 9 is divisible by 3. So we say that this 441 is divisible by 3. I'll place the check mark here. Next, is it divisible by 6? What is again the divisibility rule number 6? It has to satisfy the two conditions. First, should be divisible by 2. Second, should be divisible by 3. Now, it is already divisible by 3, right? But, is it divisible by 2? Remember, it has to be even to make it divisible by 2. But the last digit here is 1, and 1 is not even. So we say that it's not divisible by 2. And therefore, it is not also divisible by 6. How about 9? Is it divisible by 9? Let's try to add all the digits. 4 plus 4 is 8, plus 1 is 9. Is 9 divisible by 9? 9 divided by 9? Do we have remainder here if we're going to divide 9 by 9? Will we get remainder? Definitely not. So, because 9 divided by 9 is 1 without remainder. And it will make 441 divisible by 9. So we can already answer the problem above. Then we say that Chef Franco can only use or can only pack the brownies in 3s and in 9, but not 6. Again, Chef Franco can only pack all the brownies, the 441 brownies, in 3s and in 9s, but not 6. Did you get it? Since we answered already the problem, it's time for us to proceed to the math chat. And here are the questions for our math chat part. The first question is, are all numbers divisible by 9 also divisible by 3? What is your answer? Yes, it is correct. All numbers that are divisible by 9 are also divisible by 3, knowing the fact that 3 is a factor of 9. Remember, 3 times 3 is equal to 9. Okay? So by giving that example, it explains already that all numbers divisible by 9 are also divisible by 3. Next question. Are all numbers divisible by 6 also divisible by 3? Again, are all numbers divisible by 6 also divisible by 3? What do you think is the answer? Is it yes or no? Yes, it is correct. Remember, 3 is also a factor of 6. How does it happen? Remember, 6 is just equal to 2 times 3. So we say that all numbers that are divisible by 6 are also divisible by 3. Like 6, 12, if we're going to list down or name some of the multiples of 6, we have 6, 12, 18, 24, 30, 36, etc. And all of them are divisible by 3 also. Right? Alright, so let's go down to number 3. Are all numbers divisible by 9 also divisible by 6? Do you think this statement is true? Do you think the answer is yes or no? The correct answer is, it's not divisible. Because not all the numbers that are divisible by 9 are divisible by 6. Because of the first reason, that 6 is not a factor of 9. Right? But I know that there are some, to correct the statement, there are some numbers that are divisible by 9 and also divisible by 6. Say for example 18. 18 is divisible by 9. And it's also divisible by 6, right? Since that we're done already with our discussion about divisibility rules 3, 6, and 9, then that ends our discussion for today. But before I will close this video, let me first leave this question for you. Are you ready? So here's the task that I will leave for you before I'll end this video. So the task here is, I want you to find the least or the smallest missing digit to make this statement true. Again, I want you to find the smallest missing digit here to make this statement true. And the statement is 4,500 blank 4 is divisible by all 3, 6, and 9. Again, 4,500 blank 4 is divisible by 3, 6, and 9. What do you think is the missing digit? Alright, so we will answer this task or question or activity in the next video. So thank you so much for finishing this video. Before I leave, let me first invite you to my channel to subscribe and don't forget to like and share this video. Thank you so much.